Hi, I just wanted to show you some things about my telescope. This is the Celestron Omni XLT 150 Reflector Telescope. There are basically two kinds of telescopes. There are the refractor, which is the sort of classic kind of telescope where through a series of lenses the light is refracted and bent toward an eyepiece that goes to the end of the optical tube assembly. On a reflector telescope, such as this one, let me take the cap off here. We have not the eyepiece at the end, but we have the eyepiece up here. And at the bottom, at the end of the telescope, there's a large mirror called an objective. You can probably see the mirror in there. And then there's a smaller mirror right up here at this end that sits at a 45-degree angle and reflects the image of what you have the telescope aimed at from the larger mirror down at the bottom of the tube, the end of the tube, to this small mirror and then into the eyepiece, so that you can see the magnified image of what you're looking at. So the magnification of the image really takes place at the eyepiece here, and I'll explain that in just a minute. So the reflector telescope, here's the finder scope. It's a 50 power finder scope, and typically at a higher place, or at least a place that you can see, and it's above the telescope. But for purposes of the video, for things I wanted to show you on this telescope, I'd moved the tube here so that I could have things more at my ease of showing you some things. So the equatorial mount, the mount is very important for a telescope. You want a good solid mount so that it's not shaking and wiggling and the wind's not moving it, because when you're looking at something way off into space, you need everything to be steady. For example, Jupiter, to see the cloud bands on Jupiter for a telescope like this is a smaller telescope. So to see something like Jupiter, even a larger telescope, you don't want the telescope wiggling, because then you'd be missing some of the finer details. So the equatorial mount, the mount is very important. There are two types of mounts. Actually, there are three types of mounts. The azimuth mount, which would just sort of be like a camera mount, where you move it from side to side and up and down. And then there's the Dobsonian mount, which it works a similar way as an azimuth mount, you would have to keep focusing the image that you're looking at every time you move the scope. With an equatorial mount, however, you can train the telescope on an object. Let's say I want to look at the moon, and the moon, I need to have this thing sort of arranged like this. Well, as you know, everything in the sky is moving. For us, actually, the Earth is moving, but it appears as though the moon is moving, so you need to track it. So I have installed these tracking motors. I need to continue to track the moon, and because the moon isn't moving straight across the sky, as you know, it rises and then it moves up and then goes down into the west. So this equatorial mount would follow that sort of elliptical trajectory of the moon. And so it's this motion here that would continue to track the moon. So I would set it in one place, and then it would follow the moon. It would move very, very slowly as the moon sets then, or whatever you're looking at, Jupiter or the stars or something. It would continue to track the object. Now that typically isn't important to track an object, except if you want to do some photography of what you're looking at. We'll get into that in a minute too. The eyepieces, basically there are two kinds of eyepieces. And it's the sizes really. There's the 1¼ eyepiece, which I can put in my telescope. And so the 1¼ eyepiece, I'll take that adapter off here. Take the lens off. Put my eyepiece on there. So here's my 1¼ eyepiece in my telescope. So I would put my 1¼ eyepiece in there, look at whatever it is I'm trying to find, and focus it in with these focusing knobs, obviously, and then if I want to continue to track it, set my tracking motor, set up my camera apparatus and slide that into the tube, and maybe take some photos of the moon or Jupiter or some kind of nebula out in space. So also for the moon, because the moon is very bright, you may want to put some filters inside the eyepiece. So I have various kinds of filters, different colors. I also just have some like sunglass color filters, just dark ones. And these just screw into the end of the eyepiece here, and slide back into the eyepiece receiver, and you tighten that up, and now you have a filter to block out some of the harmful rays of the moon. And so when you are magnifying the moon, it is very intense light. It won't it won't burn out your retina in your eyes, but it's more comfortable to look at the moon through a filter. So this is the 1¼ eyepiece. This is a 2-inch eyepiece. And so I'll take this 1¼ adapter out of here. There you go. Put my 2-inch adapter in. And there I have a 2-inch eyepiece now that I can look at. And of course, obviously, the advantage of a 2-inch eyepiece is you have a much broader field of vision. And so if I'm looking at something big in the sky, something like a large nebula, for example, the Orion Nebula in the Orion constellation, or a star cluster that takes up a large space in the sky, very far out there. This would be very helpful when I get into the focusing position. This is a 23 millimeter eyepiece. This is a 42 millimeter eyepiece. And so the eyepiece closer look. So a 9 millimeter would get you, a much more detailed and close look at the moon, for example, than a 23 millimeter, and certainly more so than a 42 millimeter eyepiece. So the greater magnification, in other words, actually happens with the smaller number of eyepiece. So then for my camera, if I want to take some images of some things, I set this little adapter up, take the lens off the camera, and just put this little adapter in here. This locks right on there where the lens would go. And I can either just sort of shorten this up, and even I can even get I have some different applications. I can screw this out and put this knob right up against the lens and put that into my 1¼ eyepiece. Or I can take this part of it out here completely and take those screws out and put this into my 2-inch receiver in the eyepiece to get a broader field of vision. Or on this model, I can even put a lens right inside of put an eyepiece rather right inside of the apparatus here, and then it will actually magnify my image for me, and I can get a picture. So it slides in like this, and I can get a picture of what I'm looking at through an eyepiece. And so this all screws on like this, comes together, and then of course that goes into the 1¼ eyepiece receiver. As you can see, it gets this is a lot of weight for the telescope. So when you start adding things on to the telescope here, you're compromising some things and you're making it a little more unstable. So one of the key factors is to get that camera as close to this receiver here as possible, and that certainly can be done. But sometimes you do have to just have all that apparatus, which adds a lot of extra weight to it. and just sort of have to deal with that and keep it from shaking and hope you get a good image. There's some counterweights here, of course. You want everything balanced. You don't want the telescope to tip over. This is a good heavy mount, but still you want it to balance. So you kind of have to go through a little balancing routine with things here as you start setting it up and so forth. Especially if you're going to add things to the end here. I've looked at various things already. I bought this last fall for a reasonable price, less than $500. People look at this and they think, wow, how many thousands did that cost? Well, not very much at all, not even $1,000. Less than $500. I bought it brand new. It's a great little telescope. I have two other telescopes. Again, this is a 6-inch aperture. Aperture size is a big deal for telescopes. The larger the aperture, the greater the detail you can see. You think of these reflector telescopes as a light bucket, and so the light that comes in there and shines, and then it's magnified through the lens and reflected through the mirrors. I do have a refractor telescope. It's bigger, it's heavier, it's longer. I do have a 10-inch. I have a 10-inch reflector telescope. That's certainly much bigger than my 6-inch telescope here, even lengthways. Those are both my refractor is on an equatorial mount like this. It too has motors for tracking things. My Dobsonian mounted 10-inch reflector is on a different mount, and I'll explain that in another time. Here are the controls for my mortars, and there's various tracking speeds. I usually find, of course, you have to have that in the northern hemisphere, and there's ×2, there's ×4, and ×8. I typically find that ×2, the slowest one, tracks things very well, very steadily. I have what I need for a night of viewing things. I've looked at Jupiter. I can see the cloud bands of Jupiter. I've taken some pictures of Jupiter. It's hard to get some of the details with a camera. It's always better in the eyepiece. Astrophotography takes some time to learn and figure out and sort of process the images. I've got some good images of the moon. I'll probably include those in this video. I've seen the Orion Nebula, this cloud nebula. It's still producing stars in the Orion constellation. Very beautiful to look at night. Various star clusters. And it's been a fun thing to do when we get clear skies.